In our 9A notes, we're going to talk about another group of our family of functions called exponential functions. So we're just going to take a look at a couple of simple ones here and graph them. So I want to graph y equals 2 to the x. So I'll start off and let x be 0, 1, 2, and I'm going to go ahead and do a 3. And then we'll also do -1, and then I'll fill in a spot there for -2. If I put a 0 in, I get 2 to the 0 power, which is 1. 2 to the first power is 2. 2 squared is 4. 2 to the third power is 8. And then remember, 2 to the -1 is going to be 1 over 2. And then 2 raised to the -2 power is going to be 1 over 2 squared, which is 1/4. So we'll graph that very quickly. So we have a 0 and a 1, 1 and a 2, 2 and 4, 4, and then 3 and 8, which I believe is right about there. We have -1 and then 1/2, and -2 and then 1/4. Now what I'd like you to think about is if I had, say, a -3, I'm going to have 1/8, -4 is 1/16, -5 is 1/32. Will I ever get a negative answer? And the answer to that is no. And so no matter how negative I get, I am never going to cross into the negative side of this graph, and it looks along these lines. So my graph is just going to scoot along the top of the x-axis. All right, so take a second and graph y equals 3 to the x, and then check back and see how you did. All right, so you can see here the 139. It goes up just a little bit faster, and it comes down also a little bit faster. But basically, you see it has the same shape, and the green line is going to scoot along that x-axis just like the blue one did. All right, so now what happens when we have 1/2 raised to the x power? So again, I'm going to do a 0, a 1, and a 2. Then let's do a -1, a -2, and a -3. So if I put in a 0, anything to the 0 power is 1. 1/2 to the 1 power is 1/2. Square it, and I get 1/4. -1 is going to flip it, so it's going to put the 2 on the top to the 1 power, so that's going to be 2. -2 is going to flip it and square it, so that gives me 4, and then flip and cube, and that gives me an 8. So when I graph this one, then I have 0, 1, I have 1, 1/2, 2, 1/4, and then -1, 2, -2, 4, and then -3 is going to be 8 up here. So this time the line is going to move this direction. So you can kind of guess that the line g of x is equal to 1/3 of x is going to look along the same way. So I'm going to stop it and graph it. So again, here we have it. When I had 1/3 of the x, it has the same shape as the 1/2 to the x. It just goes up faster on that left and goes down faster on the right. So we're going to look at some of the characteristics of these two graphs and kind of put them all together on this next page. So here. All right, so we talked about this line here where it scoots along the x-axis, and that's called an asymptote. So this is an asymptote. A-S-Y-M-P-T-O-T-E. It's a line which the graph gets very close to but never crosses. So again, here these very simple equation that we just graphed. I have b to the x. B is called the base. It's going to be positive, so it's going to be bigger than 0, and it can't be equal to 1. So it's a number. B is always a number, and those things are true. So the asymptote for both of these two graphs in general, you can see it scoots along the x-axis. So that's a horizontal line, hoi. So hoi means I'm going to have y is equal to, and then that line is at 0. So the asymptote for both of these is going to be y equals to 0. Notice here I have them kind of separated. This is like the first group where I had b is equal to 2 to the x power. So b is greater than 1. And this is like the second group of problems where b is a fraction in between 0 and 1, like the 1/2 to the x and the 1/3 to the x. So that's the two different graphs. The y-intercept, though, for both of them, if you look back, which is where it's equal to 0, they all have that point 0, come on down here, 0, 1 on there. So the y-intercept is going to be the point 0, 1. There is no x-intercept because it never crosses the x-axis. The domain going from left to right is going to be all real numbers. So I'm going to put the R there for all real numbers. But the range is always above the x-axis for both of them. So we'll say that the range y is greater, no, not greater than, it's not equal to, it's just greater than 0. All right, it says all exponential graphs of the form y equal bx have the 2 points, and we talked about one of them. You saw where they all had the point 0, 1 on every one of the graphs that we graphed. There is also a point that we're going to call 1, and it's different. It's a little bit different, but 1, 2, it always matches the base. 1, and then there's the 3 that matches the base. 1, 1/2 matches the base, and then 1, 1/3, which matches the base. So we're going to put 1, comma b for the base on that.